Hi students, now we are going to learn what is conservation of momentum. Now in the previous video we have defined what is momentum of a body. So the mathematical definition of momentum of a body is what? Mass of the body and its velocity. Actually it means momentum means the quantity of motion associated with the body. Okay, now what is conservation of anything? Conservation of energy means the total energy must be constant. Like that, conservation of momentum we are going to explain in terms of two colliding bodies. So I have taken two marbles A and B. So the mass of the first marble is MA and its initial velocity along a straight line is UA. So I am going to roll the marble along a straight line along the x-axis with an initial velocity of UA. Now before that A, another small marble of lesser mass MB is also moving in the same straight line direction with the initial velocity UB. Now you assume that the velocity UA is greater than UB. So the larger marble will come faster than the smaller marble. So at one instant what is going to happen? A is going to collide with B. So a collision occurs and this collision will occur just for a fraction of a second. The time of collision is very short. You can see here. So A and B are colliding with each other. So before collision, what is the situation? Before collision, UA is the initial velocity of A and UB is the initial velocity of B. Now during collision momentarily, what is going to happen? Both are in contact with each other. So during this contact, A will exert a force on B and this force acts as an action. As a reaction, the body B also will exert a force on A, which is equal in magnitude but opposite in direction. This is with reference to Newton's third law. So here conservation of momentum is an application of both Newton's second law as well as Newton's third law of motion. Okay, then during collision I said that the force acting on B, the force exerted on B due to A is denoted by FBA. So the first subscript says on whom the force is acting and the second subscript says that who is exerting that force. Similarly, FAB must be what? First subscript is A, therefore this force is acting on A. Second is subscript is B, that means B is exerting the force on A. So FBA is called action force and FAB is called a reaction force. So I told you that during collision the two bodies will be in contact for a very short interval of time t. Then afterwards they will get separated. So after getting separated there are so many possibilities. Both may travel in opposite direction or they may continue the same direction also. But in this diagram I have assumed that after collision also A and B move in the same direction. But due to the impact or collision their velocities will change. So now after collision the final velocity of A is taken as VA and the final velocity of B is taken as VB. So this type of collision I have assumed it is taking place along the same straight line. So I can call this collision as one-dimensional collision. Understand? So before and after collision the two colliding bodies will travel in the same direction or same straight line. Okay, now what is the statement of conservation of momentum? Before collision, the total momentum of the two bodies A and B, these two bodies together is called a system. So I consider a system consisting of two bodies A and B. Their total momentum before collision I want to find. That is MA into UA plus MB into UB. That is the total momentum of the system of two bodies before collision. Okay. Now after collision, what is the final velocity is VA and VB. What are the individual momentums of A and B? MA, VA and MB, VB. So if you add these two, the total momentum of this system consisting of two colliding bodies after collision is MA, VA plus MB into VB. This will be always constant. The total momentum of the system before collision and after collision will be constant, provided no other external force will act other than the force due to collision. The one and only force acting between the two bodies is what? The force due to their collision. So other than this collision, no other electrical force or magnetic force or mechanical force or any external force should act on it. So my dear students, what is the statement of conservation of momentum? The total momentum of a system remains constant. Okay, when there is no applied external force on the system. So in the absence of an external force, the total momentum of the system before collision is equal to the total momentum of the system after collision. So we want to prove this. So now let us take the situation. What is FBA? So this force FBA. So what is the first subscript? I told you force is acting on B and it is exerted by A. So FBA must be equal to the rate of change of momentum of whom? On whom the force is acting? B. So it is the rate of change of momentum of B. So when the force is acting on the body B, the momentum of B only is going to change. Understand? So this is now equal to the final momentum of B minus initial momentum of B, that is change in momentum of B divided by time. So the final momentum of B is MB into VB. So MB into VB is the final momentum of B minus of initial momentum of B is what? MB into UB. So this final momentum of B minus initial momentum of B is called the change in momentum of the body B divided by the time of collision. The time of collision is T. So FBA is now equal to MBVB minus MBUB divided by T. And this is our equation 1. Okay. Similarly, what is the force FAB called as AB? First subscript is A. So FAB is the force acting on A and it is exerted by B. So on whom it is acting? On A. Therefore, this must be equal to what? The rate of change of momentum of A. Okay, rate of change of momentum of A. So because of this force FAB, whose momentum is changing? The body A's momentum is changing. So final momentum of A minus initial momentum of A, that is change in momentum of A divided by time taken. So this must be equal to, okay, therefore FAB must be equal to MA into VA minus MA into UA divided by time T, and this is our equation 2. So now look at the equation 1. Final momentum of B minus initial momentum of B divided by T is called rate of change of momentum of B. Like that, equation 2, final momentum of A minus initial momentum of A divided by time T is called rate of change of momentum of A. Okay. So first two equations have you all understood first? Okay, this is a consequence of which law of motion? Newton's second law. So according to Newton's second law only, the force, impressed force acting on a body is equal to the rate of change of its momentum. Okay, now let us apply Newton's third law. So from Newton's third law, action is equal to minus of reaction. So I will write action force is equal to minus of a reaction force. Now here FBA is called action force and FAB is called reaction force, but with a negative symbol. So action force is what? FBA. So FBA must be equal to minus of FAB. Okay. Now on the left hand side, in place of FBA, I am going to substitute equation 1. So on the left hand side it is m mass of B into final velocity of B minus mass of B into initial velocity of B divided by time t. Is it okay? So in place of FBA we have substituted which equation? Equation number 1. So this must be equal to negative of negative. So there is a negative sign. So we can use the same bracket. Okay, negative of. What is it on the right hand side is FAB. So in place of FAB, equation 2 shall be substituted. So it must be what? MAVA. So this is minus of MAVA minus MAUA. So this is MAUA whole divided by the same time t. Since the time of collision is same, we can cancel this. Now you open up the brackets. MB into VB minus MB into UB. This is equal to, when you open this bracket, first term will be negative and the second term will be minus of minus positive. So first term is what? Minus MAVA plus the second term what? MAUA. Okay. So now the negative terms you shift to the other side and make it as positive. So now here this MB into VB positive and you bring this negative MAVA, okay, it will become positive on the left side. So plus mass of A into VA and this is equal to MAUA, MA into UA. This negative term you shift to the right side. So this will become what? MB into UB. Okay. Now you see here what is MB into VB. MB into VB is the final momentum of B. Understand? What is MA into VA? That is the final momentum of A. So left hand side is the final momentum, that is the final momentum of A and B are added. Therefore left hand side is the total momentum after collision. So total momentum after collision is on the left hand side. Now right hand side, what is there? Let us see now. MA into UA. MA into UA is the initial momentum of A and MB into UB is the initial momentum of B. So right hand side is the sum of the momentum of both the bodies before collision. So the right hand side must be equal to the total momentum of the system. The total momentum of the system before collision. So before collision. So we have proved that the total momentum of the body before collision and after collision remains constant. This only is called as what? Conservation of momentum. Hence the total momentum of a system. The total momentum of a system remains constant always. So the total momentum of the system remains constant if F external is equal to 0. That means that in the absence of an external force, the total momentum of a system remains constant always. I hope you must have understood well. Fine.